In this demonstration, I want to show you that like charges do indeed repel. I've got a Van de Graaff generator here. Now this is something that generates a large positive charge. That metal sphere is going to become completely positive. I've also got my daughter touching that sphere. That means my daughter is going to become positively charged as well. Now look what happens when I zoom in on her hair. Notice what her hair is doing. It's starting to stand on end. Why? Well, the positive charge is coming from the sphere and being conducted through her hand throughout her body. So her entire body is becoming positively charged. This includes her hair. Now, since like charges repel, that means her individual strands of hair are repelling each other. Since the hair is pretty light, the force of repulsion between each individual hair is actually greater than the force of gravity holding the hair down. As a result, the hairs try and get away from each other as far as possible by standing on end. So this is a rather stunning, and for my daughter, perhaps even embarrassing visual, that like charges do indeed repel one another. Now you might think that all this electrical charge is somehow dangerous. After all, we know we're not supposed to stick our fingers into a wall socket. However, this kind of activity here is clearly not dangerous, or I wouldn't let my own daughter do it. So why is this kind of activity not dangerous, while sticking your fingers in a wall socket is dangerous? Well, a little later on, you're going to learn about current, which is the amount of charge that flows through an object divided by the time. It turns out that the danger of electricity is associated with the current. The more current, the more danger. In this situation, there's a reasonable amount of charge, but it takes a long time to develop. So the current is very low, and there's no danger associated with this particular activity. The only danger she faces here is a little embarrassment because her hair really does look funny.